All right, so hi guys, we are back once again, and we are still continuing with financial mathematics, right? Okay, so in the previous videos, we talked about simple interest, compound interest, nominal and effective interest rates, depreciation. Okay, and then in this video or in this lesson, I want us to look at annuities. Annuities. Okay, annuities. This is specifically for grade 12 financial mathematics. Okay, annuities. So, what is annuity? Okay, what is annuity? Annuity is the regular equal payments over time. Regular, let's write it down. Regular equal payments over time. Okay, over time. What are we saying in this case? We are saying, let's say I want to save so that I can achieve a certain amount of money in future, or after a certain period of time. Okay, so I will decide, and then I'm saying, okay, I want to save 100 rand per month. Okay, so those equal regular payments of 100 rand per month is annuity. Okay, annuity. Or again, when let's say you borrow a certain amount of money from the bank, and then the bank is saying, well, you can pay us 1.2 per month. So 1.2 per month, this will be, or that will be, your regular equal payment. Okay, so that is annuity. So here we have two main types of annuities. That is future annuity, future annuity, and also present annuity. Okay, future annuity and present annuity. This is what we are going to talk about in this lesson. Okay, so let's start with future annuity. What is future annuity? You now know what is annuity. Okay, what is future annuity? Future annuity is when you save a certain amount of money regularly, of course, so that you can get a certain amount of money in future. Okay, let's say savings. You are saving money in your savings account. Maybe you are doing a regular payment of 500 per month. Okay, again, you are investment. Okay, investment. Deposit, again, when you deposit maybe 500 per month into your savings account, that is future annuity. Okay, and then how do we calculate future annuity, or how do we deal with calculations involving future annuity? You use the formula which says F is equals to X into 1 plus I all to exponent n minus 1. Then you close that bracket, and then all over I. Right. So what is F? F is your future annuity. Okay. And then what is X? Remember, here you are doing regular payments, or you are depositing in your savings account regularly. So X in this case is regular payment. Regular payment. Maybe you are paying, or you are depositing 500 per month, so X will be 500 in this case. So that is a regular payment. And then I, of course, you know what is I. I is your interest rate as a decimal. Interest rate as a decimal. Okay. And remember, if we have a compounding period, you will divide your interest rate by that compounding period. Okay. And then what is N? Very, very important, this one, because we see a lot of mistakes here. Okay. N is number of payments here in annuities. Number of payments. Okay. Where can I write that? Number of payments. Number of payments. So let's say, for example, that I'm doing a deposit in my savings account for a period of 5 years, compounded monthly. Okay, and I start to deposit that. Let's say I'm depositing 500 per month. Yes, so my X is 500. So I want to represent this in a timeline so that you can understand a number of payment in this case. So here is my timeline, and I just said 5 years, right? Compounded monthly. So it means I'll multiply that 5 by 12, and then this will be 60. Okay. So here's my timeline: 0, 1, 2, 3, 4, blah 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 blah, up until 60 there. All right. So I'm starting to deposit 500 in 1 month's time. What am I saying? I'm saying that I will start to deposit this 500 into my savings account at T1. Okay, at T1. So in my N, I will say N is equals to 60. Why? Because I started to deposit in 1 month's time. So my N will remain like this. But what if I now start to deposit 500 immediately into my savings account? Immediately. Then immediately in this case, if I start to deposit immediately, then this means that I will start at T0. At T0. This is immediate payment. Immediate payment. So my N, how is going to be my N? How my N is it going to be in this case? So because I started immediately, so that 60, N is gonna be 60 plus 1, and this is 61. Okay, because I started to deposit or to do a payment immediately. Okay, but what if I started in 2 months' time? In 2 months' time, that means I started here at T2. Okay, so I skipped 1 month. Okay, 1 month. So it means I'll have to subtract N is equals to 60 minus 1, because I skipped 1 month there, and this is going to be 59 number of payments. So it's very, very, very important to choose N correctly. Okay, so that is future annuity. So let's take an example here of future annuity. Yeah, this example, let me try to, okay, all right. Okay, so they are saying SIPO decides to save. Please, those keywords, you need to be able to identify which annuity am I dealing with here. Okay, because again, people do a lot of mistakes in identifying these annuities. Okay, save. We just said savings. savings, that is a future annuity. Please be able to identify your annuity with those keywords. Okay, so Sipho decides to save 500, okay, at the end of every month. So Sipho is doing equal payment of 500 at the end of every month. So what is 500 in this case? 500 is your X, right? In a savings account, of course, this is future annuity, okay, and then or that offers an interest rate of 8.5%. Okay, so that is your I, which is 8.5%, right? Compounded monthly. Okay, so in this case, monthly means 12. So we need to divide our interest rate by 12 and also multiply the number of years by 12. Okay, and then he continues this for 5 years. Okay, so we need to say 5 multiplied by 12 and also divide our interest rate by 12. But remember, interest rate must be converted to decimal. Okay, and then how much will Sipho have in the account at the end of 5 years? What are we looking for in this case? We are looking for future annuity. Okay, the amount that Sipho will have at the end of the 5 years. So let's write the formula down. This is F is equals to X into 1 plus I to exponent n minus 1 all over I. So X 500. Okay, and then 1 plus interest rate 8.5%. So it's 8 over 5 divided by 100. Okay, this is going to give us 0.085. Okay, so 0.085. Remember they said compounded monthly, so we need to divide our interest rate by the compounding period, which in this case is 12, and then close our bracket. N, what is n? N 5 multiplied by 12. 5 multiplied by 12, that is 60, right? Minus 1, right? And then you divide by 0.085, which is your interest rate, but don't forget to divide your interest rate by the compounding period. So let's take this into our calculator. That is 500, 1 plus 0.085 over 12, and then 60, exponent 60 minus 1, and then you need to divide by 0.085 divided by 12. That is 37,221.22 cents. Okay, so this is the amount that Sipho will have in the account at the end of the 5 years. Okay, so let's move to present annuity. Present annuity. Now here the loan is saying, or you granted a loan from the bank, and now you will have to pay the loan with equal regular payments per month. That is present annuity. Okay, it deals with what? With regular equal repayments. Okay, equal regular repayments. You are repaying. Okay, in future annuity we are paying, we are doing deposits, savings, and all of that. But here we are talking about the loans, mortgage, bond, mortgage loans, and all of that. So if you hear questions saying or that is talking about loans, then that should be present annuity. Okay, those keywords, they will help you to be able to identify which annuity are you dealing with in this case. Okay, So here you are doing regular equal repayments. Okay, right. Okay, so how do we calculate present annuity? It's P is equals to X. Okay, 1 minus 1 plus I all to exponent negative n. Okay, all over I. Okay, so this is the formula that you will be dealing with, okay, or that you will use when calculating present annuity or when dealing with calculations involving present annuity. What is P? P is a present annuity. Okay, it's the loan amount that you will pay after a certain period or over time, and then X, that is regular equal repayments. And then what is I? Okay, I, of course you know what is I. It's interest rate as a decimal, interest rate as a decimal, and then N, number of repayments, that is a number of repayments. Okay, so here it's a regular repayment, and then N is number of repayments. Okay, very, very important present annuity. Okay, I will always advise people to use timelines. Okay, but if you don't know how to interpret your timeline, please don't worry about that. I'm gonna create a video where we are dealing specifically with the timelines. Okay, but for a present annuity, let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 months. 10 months. I'm repaying. Okay, maybe with. Okay, I want to emphasize this. Here's my timeline. Okay, so if you will be using timelines, please note that there must be a gap, okay, between the granting of a loan. So at T0, here at T0, this is where you grant a loan. This is where you take a loan from a bank, maybe. Okay, this is where you grant a loan. It's the granting of a loan. Let's write granting of a loan at T0. As always, this will always be granting of a loan. Remember, for future annuity, you can do immediate payment at T0. But for present annuity, it's a different story. This is granting of a loan. You take a loan at T0. What am I saying? I'm saying there should be a gap between the granting of a loan. That gap between the granting of a loan and the first payment or repayment. Okay, let's say that I am doing a repayment in 1 month's time. Okay, so it means I will start to repay my loan at T1. All right, and then what if I am or I'm dealing with a question that is saying repayment is done in 3 months time. In 3 months time, it means I am doing a repayment at T0. I will start to repay at T3, not T0, it's T3. Okay, so you need to be able to know what is N. Okay, you need to know what is N if maybe you are given a certain period and then they are saying the payment is, or the repayment, the first repayment is done in 3 months time. Okay, that's what they usually say, in 3 months time. Okay, so you need to be able to know what is n. So if they are saying in 3 months time, you will subtract the period. Maybe let's say it's 5 years multiplied by 12, that is 60. So you need to subtract 2 from 60, because you started to repay at T3. Okay, so please ensure that I will always recommend everyone to use timeline. Okay, because it's very simple and it helps you to understand those questions that seems to be more likely be challenging, but trust me, there's nothing that is difficult here. So let's go to the question, which is saying, let me try to zoom. Okay, Lebo wants to take out a loan and repay 2,000 at the end of each month for 3 years. So what is that 2,000? That is your X, right? So this is my X, right? And then at the end of each month for 3 years, and the bank offers an interest rate of 10% per annum. This is my I, per annum compounded monthly. All right, what is the present value? Okay, we are looking for P. So you need to collect data. I've got X, I've got 3 years, I've got 10%, and the compounding period. So let's write the formula down. P is equals to X 1 minus 1 plus I negative N. It's negative here, okay, but you don't have to worry about the formula because it's there in your data sheet. So X 2,000, okay, 1 minus 1 plus the interest rate is 10%. You need to convert that. So it's 10 divided by 100. This is 0, 0.1. Okay, so 0, 0.1 divided by the compounding period. They said compounded monthly, so we need to divide by 12. Right, and then negative 3 years, so that is 3 multiplied by 12. Okay, compounding period, so it's 12 multiply by the compound period, which is compounded monthly. Right, so that is 3 multiplied by 12, then close your bracket, divide by 0, 0.1 interest rate, but you divide it by 12. So it's 2,000, 1 minus 1 plus 0, 0.1 divided by 12 to exponent negative 3 multiplied by 12 all over 0, 0.1 divided by 12. This is equals to 61,982.47, and that is your final answer. Okay, good people, we will do more activities on annuities. Okay, yes, and we will still continue with financial mathematics, outstanding balance of loan, yes, also sinking funds, and then we will continue with doing past exam papers. Okay, so I'll see you guys next time. Sharp.